Fluidized bed combustion technology is mainly applied for low-grade, high ash content fuel such as coal and agro waste like paddy husk, etc. Fluidized bed combustion technology provides for homogeneous mixing of fuel and air at a steady bed temperature to realize complete combustion of the fuel. It is designed for precise control of the 3 T's of combustion: time, temperature, and turbulence. This mechanized combustion system gives consistent performance and minimizes the need for skilled labor. Mechanized fuel feeding and ash handling ensure consistent output and high thermal efficiency. This type of combustion system is the simplest. It is used for burning fuels which need a liberal quantity of primary air supply through the fuel bed for complete combustion. The system is best suited for burning high-grade fuels such as coal and wood chips. Since fuel needs to be fed manually, a skilled fireman is required to do the job. He must ensure proper fuel feeding, its uniform distribution on the grate, proper ash removal, and must monitor and maintain a proper fuel feeding rate to correspond to the heating load pattern. It is widely accepted that an automated process is more efficient than any manual process. The Traver-grade combustion system is engineered for this efficiency. Fuel feeding and ash removal operations are mechanized and independent of one another. Air supply is uninterrupted to match the requirement. This assures positive fuel and air mixing characteristics with minimal excess air supply. The process also eliminates the cost of skilled furnace operators. An undisturbed fuel bed minimizes fly ash emission, reducing ash deposit in the heat transfer area, thus increasing heat transfer efficiency. An even bed of fuel eliminates the hot and cold zones on the grate. This ensures consistently high combustion temperatures across any given section of the fuel bed and minimizes ash clinker formation. Thermax's thermic fluid heating systems are provided with combined deaeration and expansion tanks. Thermic fluid returning from the process enters the deaeration tank tangentially, creating a vortex. This facilitates the vapors, air and gases trapped in the thermic fluid to rise through the vent pipe and be released into the atmosphere. The deaerated thermic fluid is pumped into the thermopack for another heating cycle. The combined deaeration expansion tank in the thermopack has an integral buffer vessel and expansion tank. As the thermic fluid expands due to heating, it pushes its way into the buffer vessel and then cools and rises into the expansion tank. In case of multiple installations, separate deaeration and expansion tanks may be provided. Combustion air required for firing in the furnace is channeled through an air preheater for preheating before it is pumped into the furnace. This technique of providing preheated combustion air has a dual benefit. It allows for maximum heat recovery, and preheated air in the combustion chamber facilitates complete combustion of fuel, ensuring better energy efficiency. Heat is picked up by the thermic fluid from the thermopack and transmitted to the process. The balance unabsorbed heat comes back with the thermic fluid to the thermopack in a continuous heating cycle. This type of closed-loop heating ensures utilization of the return heat and thereby a highly energy-efficient system. Thermax's thermic fluid heating systems are engineered to such optimum levels that deliver maximum benefits. The hot products of combustion transfer most of their heat to the thermic fluid in the radiant coil, and the balance heat is transferred to the returning thermic fluid in the convective coil. In this way again, the thermopack system is optimized for maximum energy recovery. Further, the energy efficiency of the thermopack is demonstrated in the air preheater, where more of the balance heat from the flue gas coming from the convective coil is used to preheat the combustion air. As the flue gas maneuvers through the thermopack system, heavier ash particles drop to the bottom of convective coil chamber and the air preheater. Lighter ash particles that are carried further by the flue gas are trapped in the pollution control equipment. Thus, the thermopack system ensures minimum particulate matter release into the atmosphere. This safety feature ensures a consistent flow of thermic fluid through the heat exchanger. In case of low flow condition, the orifice plate assembly stops the FD and ID fans and sounds an alarm. An additional differential pressure switch is provided across the inlet and outlet to check the pressure drop across the heat exchanger. This additional safety feature cuts off combustion air and sounds an alarm.